In this video, I want to discuss another helpful theorem for showing triangles are congruent. This one's called SAS. We're going to have two pairs of corresponding sides, and we're going to have two pairs of corresponding sides that are congruent, and we're going to have a pair of angles that are congruent, and the angle is going to be between the pairs of corresponding sides. All right, so for example, if I had two triangles and I really wondered if they were congruent, and let's say one of them had, this one had side length 4, and then side length 5, and let's say this was 30 degrees and 30 degrees. And what if I didn't know anything about the other angles, and I didn't know anything about the third side length for each triangle? Turns out that that's unnecessary. Okay, we've got two pairs of corresponding sides. That's an S and an S, and notice the angle in between them, that we have a pair of corresponding angles there, so that's our A. Okay, so that's sufficient to prove that these pairs of triangles are congruent. All right, now let's talk about why that is true. All right, so this time imagine that I went to Home Depot and I bought myself 2 sticks. Now these 2 sticks, you can make them whatever size you want. They don't even have to be the same. So there's 2 purple sticks at the bottom, and what we're going to do this time is we're going to weld them together to make a triangle. Okay, now however, we're going to weld the ends together. However, we can't just weld them making any angle we want. I'm going to specify the specific angle. So just like I had 30 degrees there, let's say, I don't know, whatever, maybe it was 20 degrees or 16 degrees, whatever. Well, let's stick with our example. Let's say that I had a stick of length 5, and let's say I had another stick of length 4. And so I'm forced to weld the ends together with a 30-degree angle. All right, so I'm looking at this situation. Okay, now can you see that if those guys are welded at a 30-degree angle, there's really no choice for what the third side length is? Okay, there is no way that I'm going to be able to get anything else except for one length to fit in the open space there. Okay, that one, that green stick, whatever length that is, that's all that's going to fit there. You're not going to get a bigger or a smaller one. So this is why SAS is powerful enough to guarantee that the 2 triangles are congruent. Okay, you might say, oh, well, maybe I can beat the system by welding not the left end but the other end. Okay, so let's try that. So let's say that's about the only thing we can do without violating the request, or the conditions, the requirements. So 5 and then 4, and we did a 30 that way. Okay, well, once again, there's only one stick that's going to fit there, that green one. You're not going to get a bigger or a smaller one. And can you see that all you've done is you've created the same triangle as I drew? It's just they're both triangle. I'll put a circle around them. Both of these circle triangles are the same triangle. They're just reflected versions, flipped versions of each other. Okay, so you didn't succeed in making a different size or a different shaped triangle by doing that. So SAS is powerful enough to guarantee that 2 pairs of triangles are congruent. All right. Notice that you didn't need to check all the sides, even though to be congruent, you do need to have all the sides congruent. All right. The point is, this is a shortcut. This is sufficient, is what I'm trying to say. It's sufficient, and then it's a shortcut. And from there, you can you can stop there. You know that if you did check all the other angles and sides, you'd have corresponding pairs. Okay. All right, so let's do an example of this. Suppose that this time I had a triangle. And this time we don't know that it's isosceles. I did a previous example where I said that they were isosceles. So now we're maybe the beads of sweat are forming, maybe not. Let me give it a name. The vertices a name, I mean. So we'll call this A, B, and C. And I'm going to draw a stick from point vertex C to the opposite side. Okay, and once again I have the midpoint, so I'll call that M. So M is the midpoint. I keep saying once again because in a previous video I did something similar. M is the midpoint of A, B. That's a given. Okay, and we also, this time, we also know that angle CMB is a right angle. Okay, that's all we have. Is that enough to prove triangle ACM is congruent to triangle BCM? Okay, so let's see if we have enough to pull it off. All right, so we start listing what we can gather from the given information and see what happens. So clearly, because M is the midpoint, we know that we've got we have AM is equal to BM. Okay, so that's giving us a corresponding pair of let's see, how would you, a pair of corresponding congruent side lengths, so that's an S. Okay, we know that CMB is a right angle. Okay, now we also know that both angles share the red side. CM is equal to itself, so we know that that is another pair of congruent sides. All right. Now, would you agree that you have a straight angle? Would you agree that angle AMB, the measure of that is 180 degrees? Okay. So it's a straight angle. So if CMB is a right angle, then clearly CMA must also be a right angle. Okay, well that means that angle CMA is congruent to angle CMB. Okay, that is the A that we were looking for. So the triangles are congruent by SAS. That saves the day. Now that shows you that those two triangles are congruent. Okay. Now, let me warn you about one thing, okay? I said it, and this is important. Notice that the A goes in between the two S's, okay? If you had a situation where the A was not in between the two S's, then you can't guarantee that it's going to work. So in other words, if you had something like SSA, okay? If you have a triangle and you have two sides that are congruent, okay, and you've got let's say an angle somewhere, okay, so let's say this was, I don't know, 6, 3, and let's say we had 30 degrees, okay? Well, it turns out you can do this sneaky trick. Watch this. You can do something like, you could have 6, and then I could put the 3 like this and stretch it this way. Okay, so the point is I have S3. There's a way to draw it. Maybe I didn't draw it perfectly, but the point is there is wiggle room if the A is not in between the two S's. The corresponding pair of angles is not in between the corresponding pair of sides. Okay, so don't think that SSA is good enough. SSA is not good enough. It has to be SAS. Now, sometimes it'll be good enough, but in general, it won't. You can't guarantee that it's always going to work. All right, so keep that in mind.